is basically line of sight, and so if you have something like a hilltop in between you, you can't talk to whoever's on the other side of the hill. But if you put something on the top of the hill that both of you can see, you get to chat with each other. So,
right now.
Thank you.
You want to know what a repeater is? The microphone and the speaker pair. That's a repeater.
It makes the signal louder, but that's really important. The next question, which Jeff, I'm going to want you to go into a little bit more on Deathball, but is basically there's a lot of also infrastructure behind the scenes, and I would like folks now to talk, and I'll give you just any order you want, to talk about the infrastructure that's behind the scenes and what sort of backup power and what sort of resilience does it have during a disaster. So it's like we know Spectrum and CenturyLink have 2 to 4 hours before they go down, because depends on usage. And so my question is, when there's no power, what's going to happen to the system that you are representing?
This is about to run out of juice. Yeah, but let's just keep using this till it drops. So for GMRS radio, there are sort of 2 pieces to it. If we're using a repeater, we're dependent on the backup power for the repeater. The Deathball Mountain repeater happens to piggyback on Elevate's backup power system, so it is very robust. No drops during the recent ice storm. I don't know, Jeff can tell you how much projected backup time they have. Yeah, it's not on grid power. Even if that repeater were to fail, as long as you have power to charge your GMRS or FRS radio, you can connect to another radio of the same type. That's usually limited to maybe 3 or 4 miles. If you read the packaging, it always says 38 miles, more or less. That's true if you have 2 mountains that are 38 miles apart and you have a radio on each mountaintop. It's possible that would work. Mostly it's limited to a mile or 2. But you can still communicate with everybody in your general vicinity. If you needed to get information out of the valley, you could attempt a radio relay. Everybody in the audience and us up here have probably played telephone. That game where you whisper the message to the person next to you in a circle. That's one of the problems with any kind of relay system. But again, the more important the information is, the easier it is to get out. So essentially, when it comes down to it, in the last ditch effort, any handset radio is not dependent on anything except for the next door handset radio that you can talk to and your ability to keep it charged.
So for amateur voice radio, it's kind of similar to GMRS, except we have some more options available to us. So we can do simplex. We can have powerful stations installed at our home or in our vehicles. We have the ability to use more than one repeater in this area. So we have a amateur voice repeater on Deathball. Uses the same backup power system. It's primarily solar, the backup propane generator. So it's not attached to the grid at all. So if your grid power goes down, it doesn't care because it's not on the grid. With amateur radio in this area, we have one other repeater site on Mount Hagen that is primary grid backup battery and generator. It has handheld radio coverage for amateur radio, and it's attached to a very large network of repeaters. It's over 50 repeaters that cover most of the state of Oregon. So getting a hold of someone in an emergency is very likely on that system because it's attached to so many other repeaters across the state. If you have a mobile radio or a radio installed at your house with a nice antenna outside, there's other options as well that you can get into. I'm not going to list all of them, but the next one along the line is on Indian Ridge out south of Cougar Reservoir. And all these repeaters get back into Springfield and Eugene where there's lots of people listening. So with amateur radio, it's very similar with GMRS. I think as a user, the main thing is having power options for your radios, making sure that you keep your stuff charged and you have the ability through one means or another to recharge your batteries, either that having like a portable battery device like a Jackery or a generator or some other sort of solution, solar power for instance, which doesn't work as well in the wintertime, so generator or backup battery is probably the better idea.
Regarding ARDN mesh networking, ARDN stands for Amateur Radio Data Emergency Network. The infrastructure required to set up an ARDN mesh network is pretty broad. It can run completely on the internet, it could run on fiber optics, or it could run on radio links. These are microwave radio links, typically 5 megahertz, sometimes 2.5 megahertz links. The infrastructure required to distribute those signals are dish antennas about this round. Maybe you saw one I have in there, and some of them are about this round. They need to be on the top of buildings or on the top of mountains. These systems are often mounted back to back like this to act as relay sites to bring a signal up to the mountain, then over to the next mountain, the next one, the next one. So you have this upper level communication called a backbone. These are assembled by amateur radio operators who are devoted to this type of project. At this time, there are approximately 400 of these stations throughout the state of Oregon and many, many more in California, and this system is a worldwide network. The network in Oregon is its own island and depends upon the contributions of amateur radio operators, and as they form alliances with various agencies who provide say a data center that's secure and has continuous power and backup power, etc. Also might go into either just a handshake agreement or a memo of understanding agreement that allows for the placements of antennas on top of the roofs. These could be hospitals, fire stations, police, all sorts of, it can even be private entities. There's no reason that can't be. You have this linked network of radios that can communicate to each other. You also need to have computer services that sit down underneath that. It's not just the communication, but where do you store your files? So you have to have some computers there that can store files, or in the case of a telephone system, perform switching and routing services and voicemail services and that such. So that's what's behind the scenes of an ARDN mesh network. You wouldn't even see that at a home installation. And I neglected to mention the parts and pieces at home. Essentially, the router, which is a $50 device, your existing home computer, and if you're interested in having an IP telephone, that would be about $100, so you could dial anyone else on the network that had an equivalent telephone. So